Hello and welcome to Calculus Lesson 10. This is quite the doozy, so we're going to fly through this lesson today. And we're going to start by graphing parabolas, one of my favorite things to do. Now, in calculus, you don't really care about the exact graph. You can use your graphing calculator for that. Instead, you care about a good estimate that shows you at least where important things like zeros are happening. So, how do we find the graph of a parabola? Well, first we have to complete the square. And this should be a review, but let's go through it rather quickly. So, I'm going to factor out the -2 because we can't complete the square unless we have just x squared by itself. I'm going to leave the -5 out there because that is not part of it. Now, we take this number in front of the x, right here, 4, we divide by 2, and we square that. Turns out, 4 divided by 2 squared is still 4. So I'm going to add 4 here. Now, since I've added 4 to this side of the equation, I must also subtract, or in this case, add 8. Now, you might go, Mr. Valena, if you added 4, you need to subtract 4, right? Wrong. The reason why that's wrong is because I've actually added -2 times 4, which is -8. So I must counterbalance that with +8. An important catch, I hope you saw that. Here, -2 times 4 was added -8, so I need to balance it with a +8. From there, I have -2 times, I'm going to complete the square here. Remember that completing the square is simply you doing this formula backwards. So a plus b squared, you can see that on screen, kind of, is a squared plus 2ab plus b squared. So we're going from this form into that form, back over here. So I have the form a squared plus 2ab plus b squared. I need to simplify that down to a plus b squared. -5 plus 8 is 3. Now, what does this tell us? By completing the square, I can find the vertex and the direction. So the vertex is really easy to find. It is the opposite of this number for the x and this number for the y. So the vertex for this parabola is going to be -2, 3. The direction is going to be the sign of this number in front. If it's negative, it points down. If it's positive, it points up. So if I were to sketch this parabola, I would go -2 and up 3. There's my vertex. That's this point right here. And I know that it points down because this is negative. So I'm going to go down from there. Not perfect, but it's just about all you need for this class in order to be able to do what you need to do, which are much more complicated problems. So now they could ask you to do the opposite problem, which is finding the quadratic function whose x-intercepts are -3 and 2, and whose y-intercept is 3. So how would I do that? Well, I remember the formula y equals x minus r1 times x minus r2. What this does is it gives you, you can plug in the two roots. Sorry, there should be an a up there. You can plug in the two roots here, in this case, -3 and 2, and that gets you your parabola. The reason why they give you the y-intercept is so you can determine what the value of a is. So let's multiply these out. So y equals a, x squared plus x minus 6. I want the y-intercept to be 3. It's currently -6. So a is going to have to be, let's do some quick mental math. Looks like -1/2. And that's it. If they ask you to graph it, you already have the y-intercepts and the x-intercept. Y-intercept is 3, x-intercepts are -3 and 2. There's no way to make a curve go this way and also go through that point, so it's going to have to go like this. All right, now that would have been our whole lesson if this was Algebra 2. That's just the beginning. So let us continue. There's a really cool theorem, and you may not have noticed it when we studied division of polynomials back in Algebra 2. But if you take a polynomial and divide it by some binomial, then the remainder is actually the value of the function at that point. So let's do an example. What is the remainder when the polynomial x cubed plus x squared minus x plus 1 is divided by x plus 2? So again, I have this polynomial and I'm dividing it by x plus 2, which means my factor is really x equals -2. Now let's see what happens here. Well, I'm going to do my long division and I'll teach you a faster way in just a second. So I'm going to kind of fly through this. X goes into x cubed, x squared times, multiply this out. Change the sign in a different color so you remember that you changed it. Those go away. X squared minus 2x squared is minus x squared. I'm going to bring down the next one. So x goes into negative x squared, negative x times. Changes the sign in a different color. These cancel. 2x minus x is x. Bring down the 1. X goes into x one time. Change the sign. And the result is remainder, -1. Now, you can test this on your own, but I am telling you that if you were to plug in -2 to this top function, you would also get -1 as the value, because the remainder theorem guarantees that the remainder after division is the value of the function. So for some uglier functions, that might save you time. Now, you asked here, you might ask me, well, that took more work than just plugging in -2. That's true, but if you remember synthetic division, which is a really cool trick, which allows us to do division faster, then it might actually take less time. This is the process for synthetic division. So I'm going to do this exact same polynomial, and you're going to notice that a lot of the numbers, in fact all of the numbers, are identical because it replicates division. So what I'm going to do is I'm going to take x cubed plus x squared minus x plus 1 divided by x plus 2, and I am going to look for what factor or what value of x makes the bottom 0. That is x equals -2. Now, since I have x equals -2, I'm going to put that in a little box right here. Then I'm going to write out the coefficients of each of these numbers in descending order. So from the x cubed all the way down to 1. If you're missing any, you put 0, just like you would in division. So I have 1, 1, -1, and 1. Now here's the fun part. You're going to bring down the first number, then you multiply your dividend by that. So -2 times 1 is -2. Then you're going to add these. So that gets us -1. Notice it's the same thing here. Then -2 times -1 is 2. Now I'm going to add these. I get 1. -2 times 1 is -2, and I get my -1 remainder. Now, what does this tell us? Well, this tells us the exact same thing as this does. Let's replace the x's. So I'm just putting in the coefficients. It's always going to be one lower than the highest power of before, and that gives you your division. So it's a much faster way to do division than you've done in the past. Woo! Now, if this was a pre-calc lesson, that would be the end of it, but there is in fact more to this lesson. So let's continue. The rational roots theorem is a wonderful theorem that helps us find roots to ugly polynomials. 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 I don't know. Anyways, so we are going to find the zeros, or the roots of the function x cubed plus 2x squared minus 2x minus 4. So if I want to find the zeros, I really have no tricks up my sleeve, right? I can't use the quadratic equation because it's a cubed function. And so my best bet is to start plugging in numbers, which sounds miserable. And so I want to narrow down the focus of the numbers I'm plugging in. And this is the way you'll do it. So the rational roots theorem says this: if I take all the factors of my constant divided by all the factors of my highest power, those are all of the possible roots that are rational numbers that exist. There might be some irrational numbers that we have no hope of finding anyways. But if our root, if the zero of this function, or the zeros in this case, can be written as a fraction of two integers, it will be in this list right here. How do you generate that list? Well, what are the factors of 4? Well, easy ones are 4 and negative 4, right? Those go in nicely. And of course, 1 and negative 1. What else go in? Well, what else goes into 4? How about 2 and negative 2? Now, what are the factors of the highest power coefficient? Well, that's 1. So I have plus 1 or minus 1. Now here's where it gets ugly. You're going to have to divide every one of these combinations. So the possible rational roots of this function are 4 divided by 1, which is 4. 4 divided by negative 1, which is negative 4. Negative 4 divided by 1, which is negative 4. Negative 4 divided by negative 1, which is 4. 2 divided by 1, which is 2. 2 divided by negative 1, which is negative 2. These are already covered. And then 1 and negative 1. So these are the possible, not even guaranteed, zeros of this function. Now I have to take these and plug them in and find out if they are zeros. Now, plugging them in might be painful, right? I don't want to cube 4 and then all that. So you could use what we learned seconds ago with our synthetic division. Plug in 4 in the little box, write out the coefficients 1, 2, negative 2, and negative 4, and then go from there. But that is the easiest way to do it, other than using your calculator to help you make an educated guess. And that, my friends, is problem set 10.